Welcome to AI in 8 minutes or less, your daily AI update. Today, we're diving into a huge shift in artificial intelligence. What was basically science fiction just a little while ago is becoming reality right now, as AI is developing abilities that are really poised to change everything. This question? It's not hypothetical anymore. We're actually seeing systems emerge with real memory, with agency, and with the power to solve real-world problems all by themselves. So, what's driving this incredible change? Well, let's start by taking a look under the hood. See, it turns out these new AI superpowers don't just come from making things bigger. They come from making them smarter. And it all starts with this quiet revolution happening in the hardware that powers AI. The very engine driving all this progress has been completely reimagined. At the heart of all this are neuromorphic chips. Now, think about the difference here. A traditional computer chip is kind of like a giant 8-lane highway, just blasting everything through at full power all the time. But a neuromorphic chip, it's more like a city grid, where signals only fire and use energy exactly when and where they're needed, a lot like the neurons in our own brain. It's a completely different way of thinking about computation. And the difference is just staggering. I mean, Intel's Loihi-2 chip, for example, can slash energy use by up to 100 times compared to a regular GPU. This massive leap in efficiency is what makes it possible to run these incredibly complex AI operations for way longer without needing its own dedicated power plant. This new design also allows for incredible scale. For instance, Intel's new system now packs 1.15 billion artificial neurons. And a number this big isn't just about raw power, it's about complexity. It lets the AI model understand much more nuanced, interconnected problems than it ever could before. It just goes to show you the hardware isn't just getting bigger, it's getting smarter. So what's the real-world impact of all this efficiency? Well, it means that supercomputer-level AI is no longer trapped in some massive data center. It's becoming small enough and efficient enough to run locally, right on the phones, laptops, and all the devices we use every single day. Okay, so with this new, smarter engine, what can AI actually do that's so different? Well, this is where we see the most dramatic shift. AI is evolving from a simple assistant that we command into a proactive operator that can manage entire workflows completely on its own. Think about this progression for a second. We started with AI as a simple tool, for single tasks. Then we moved to AI teams, these multi-agent systems where different AIs take on specialized roles. But the final step, the one that's happening right now, is the AI operator, a single system that can manage a complex process from start to finish. A huge part of this new capability is memory. We've seen this recent explosion in what we call context windows, with some models now able to handle over 1 million tokens at a time. This is the AI's short-term memory, and it has just become absolutely massive. To put that in perspective for you, that's like an AI reading an entire novel or a super complex software codebase and remembering every single detail, all at once. This ability to hold so much context is what lets it tackle these long, complicated projects without losing its place. But maybe the most crucial new skill is self-correction. Before, one tiny error could derail an entire AI process. But now, frameworks like Reflection let an AI test its own work, spot its own mistakes, and automatically fix them. And the fact that this can raise a coding test's success rate from 80% all the way to 91%, that just shows you how much more reliable AI is becoming. So when you combine that massive memory with the ability to self-correct, the AI just transforms. It stops being this clever but kind of forgetful assistant that needs constant supervision and becomes a dependable partner you can actually trust to get the job done right. All right, so we've got a smarter engine and a more capable operator. But what does this actually mean for the real world? Let's look at the tangible, world-changing impacts we're seeing right now. Okay, check this out. Here's a huge example for medicine. Historically, about half of all drugs failed in early trials. But for drugs designed from the ground up by AI, that success rate has skyrocketed to over 80%. This isn't just an improvement, it is a complete game changer for healthcare. And it's not just about success, it's also about speed. The timeline for discovering a new drug, which used to take around 6 years, is now being compressed to under 18 months in some cases. AI is just accelerating the pace of medical innovation at an incredible rate. It's also solving problems that have stumped scientists for decades. I mean, take protein folding, one of biology's biggest challenges. Google DeepMind's AlphaFolds has now predicted the structure of nearly every single cataloged protein known to science. This is a monumental leap in our fundamental understanding of life itself. So the big takeaway here is that AI has graduated. It's no longer just a tool for optimizing spreadsheets or writing emails. It has become a core engine for fundamental scientific breakthroughs that are going to impact all of our lives. So, with these incredible leaps in hardware, in autonomy, and in real-world impact, we're left with the big question: what comes next? And really, this is the question to leave you with. For decades, we've looked at technology as a tool to be directed. But as AI becomes this more autonomous partner, our relationship with it has to change. Our role might shift from being a commander to a collaborator, from an operator to a strategist. What that looks like? Well, that's what we all get to figure out next. If you enjoyed this, subscribe to AI in 8 minutes and never miss what matters.